Alrighty, so we're back for the third explanation video for the electroscope demos. Again, this is for electroscope demo 3. So in that particular video, what we did was we took a negatively charged rod and we touched it to the electroscope this time just to see what was happening. So in the previous two videos, we charged the electroscope by induction. In other words, we gave the leaflets a charge by bringing a charged object close but never ever touching it. Here what we're actually doing is touching the electroscope with the charged rod, okay? And so like the other examples, we started with a neutral electroscope, which we're going to do here. So every positive needs a negative here on the electroscope, okay? Every positive needs a negative. And what you have to think about is if there's a whole bunch of electrons here on the rod and the electroscope is neutral, and again the rod is negatively charged, what will the electrons want to do? Okay, so we have a situation of disequilibrium. There's an unequal charge distribution of the rod on the rod versus the electroscope. This rod has a huge negative charge, the electroscope doesn't. So what tends to happen is that unequal charge distribution, okay, it's like this right now, tends to equalize as electrons move. And so what's going to happen here is electrons are actually, because the rod and the electroscope are touching, electrons are actually going to want to jump or move. I shouldn't say jump. They're going to move from the rod to the electroscope. So the electroscope is actually going to get some of those electrons to try and even out the charge difference between the rod and the electroscope. So we go over here to the after diagram. Again, we're going to add, enough electrons here to make it neutral, and then we'll use that as our baseline and add more electrons beyond that. Okay, so you can see right here the rod has less electrons. Well, why? It's because the rod lost electrons to the electroscope. So we're just going to add, some electrons, to the electroscope, kind of like this. Now you notice by positioning extra electrons on the electroscope like this, what charge do the leaflets get? Well, it's negative. In fact, the whole electroscope as a whole is negative as well. There's extra electrons on the sphere, there's extra electrons on this center part of the electroscope, and there's extra electrons in the leaf. So the whole electroscope has a negative charge, including the leaflets. And again, they got those electrons from the rod because of contact. And when you watch the demonstration, you should have seen that when the electroscope was touched by the negatively charged rod, the leaflets spread apart. And that's because they got extra electrons. And so what we can add here as well is, this double arrow like we've used in the other videos, that there's some repulsion going on here. So overall, here's what happened. Electrons, again, jumped from the rod, or moved from the rod to the electroscope on contact. The electroscope was filled with extra electrons, including the leaflets, so they end up with a negative charge. And again, like charges repel, and the leaflets end up repelling each other. Now, why do the electrons want to move from here to the electroscope? Well, we talked about balancing the charge, but what's the actual force that's getting those electrons to move? Well, there's a pushing force. If all these electrons are negatively charged and they're all kind of squeezed together onto the rod, they're going to repel each other. So there's this pushing force that's going to get those electrons to move from here to there as well. Okay, so we'll see you in the fourth video, and hopefully you're able to get through this stuff a little bit more effectively with these videos.